So, good morning, everyone. And as you already know, we have started with the data structure and planning to learn the new topics. Obviously, what we have seen in the last session was a quick recap. I'll go through. We just begin with learning what do we mean by data structure, correct? What data structure needs, what is the data structure as an abstract data type, then a rough classification of a data structures that we have seen, right? Then we went ahead, we talked about how the efficiency of a data structure will be measured. It could be on a space front or it could be on a time front. But at the same time, it might be kind of an exact analysis or it could be like asymptotic analysis. The exact analysis usually doesn't make any sense because it is very much machine configuration dependent, machine architecture dependent. So usually we look for asymptotic analysis. And into the asymptotic analysis, we mainly look for the big O notation, which is usually representing a kind of upper bound, the maximum one, the worst case kind of scenarios that you more worry about in the real world. And then once we also take a look at the roughly what all different time complexities could be. But then this is just a conceptual discussion. So then we went ahead. We talked about like a linear search. We written algorithm, and I guess linear search was very simple. You want to start from the first element, reach to the last element, and compare with each and every element. It was very simple process. But after that, we talked about like a binary search, where each time you are dividing array into the two parts, and then you decide whether the middle element is the element that you are searching, or if the element that you are searching is greater, you say that I will focus now on a right partition, or if the element that you are searching is a smaller, then you can focus on a lower partition, left partition. Obviously, binary search do expect that your arrays are binary search do expect that your array is already in a sorted order. Obviously, since we are learning the Java data structure using Java, at times we are definitely using some of the Java functions which are like close to that, like some of the functions that we have seen yesterday. And I have directly used like arrays.sort method because I do not really want to waste my time into like sorting. Yes, sorting is definitely we can learn separately, but when the things are available ready-made at place, we have used it. Or like another method that we have used like arrays.toString method, just to print the array into the stringized form. Then once we learn basics of linear search, binary search, we talked about recursion. And I guess we had done enough of discussion on recursion, how to write the recursive program, how to how recursion programs are executed internally, what happened to that, like a mathematical front, and etc. etc. So yes, how the functionality which are records are created onto the stack, and how all the way story goes. So like whole stuff we try to discuss in a step-by-step manner. And after that, we try to write the same binary search algorithm once again in like a recursive manner, saying that, okay, if the element is smaller, repeat binary search for the left partition, or if the element is greater, then repeat binary search for the right partition. And this is the probably logic that we put in. And after that, we say that now it's time that we can go ahead and we talk about the like what is that sorting algorithm. And after sorting algorithm, yes, we started discussing the selection sort first. The selection sort first. Not only we discussed the sorting algorithm, we discussed like one time, two time we are done on paper. Then we went back, we implemented in a Java code as well. And after that, I guess it is comfortable. We also seen the time complexity of the little selection sort. I told you a bit thing about what is that assignments, and then I guess now enough is done. I'm very sure you must have also done this sort of assignment. ये भी आप लोगों ने करके देखा होगा that how we can do, or like if at all you want to make a kind of a generic method, that was like one of the assignment that was made available. I'm very sure many of the concepts you might have learned in a Java. It is just matter of revision. I always believe that learning data structure in Java should help you to understand Java collection framework better. So you always use arrays.sort method, and that takes comparator for you. But then how that comparator internally works, probably if you at all want to know that how that comparator internally work, what you need, you need to probably write your own sort method and you need to call the comparator. And that is what probably the assignment was. So I always recommend that more assignments that you will be doing, you will be like bit more comfortable. Things will be tricky and better. That is the reason I'm saying that the people who are good at, basically Java and all that, they can definitely help other. They can, you people can discuss together and then come up with like some good results. I guess that is like enough of introduction. And now it's time we can go a step ahead and we can start talking about the next algorithm. Today we are planning that we will talk about like a bubble sort, then we'll talk about like an insertion sort, and after that we will move on to the linked list concepts. So linked list concepts using Java, how we can write, how we can implement it, and etc etc. Yes, we will talk about that, and we will see how much linked list that we can cover. So maximum, like there are two three types, four types of linked lists are there. Definitely we will try to cover at least one type of linked list, and usually the first linked list I spend enough time, I go bit slow so that you can do the paperwork, you can write the code with me. Anyway, now let's get started. I hope there are no questions as such. If anything is there on every day, you should not really wait. So every time you join a meeting, it is like a good time that you have got any question, you should have posted it. Anyway, let's get started with the bubble sort. Should we? Yeah. Thanks for your kind permission. And then we'll talk about what is bubble sort. What is bubble sort? Again, I'll first tell you the concept. I'll first tell you the philosophy, why it is called bubble sort. But to understand bubble sort, you must have played in water sometime. So, in your childhood, you might have played with the water, and then you might have seen that some, you just play some tricks, and then you find that some bubble is like generated at the bottom of the water. If at all you have seen some bubble is generated at the bottom of the water, you will always find that the bubble will scroll up. The bubble will scroll up, the bubble will scroll up, and that will come, on the top. So this is something that we say usually. But if you have ever noted, if you have ever noted, you must have seen that as bubble just start growing, as bubble start coming up, it grows in a size, and then when it is probably at the surface, like at the highest size. This phenomenon, if you ever seen it, I would say that the bubble sort do something similar one. So what exactly it does? The bubble sort, you start scrolling. You start scrolling means what? You start comparing two consecutive elements. You start comparing two consecutive elements, then next two elements, then next two elements, next two element, and you ensure that if the left side element is greater than right side element, if left hand side element is greater than right side element, then you simply swap. Then you simply swap. If it is greater, then you swap. If it is not greater, you don't swap. So what happened with this? What happened with this? In this way, the greater element will slowly go at the end of the array. So जिसको हम लोग कहते हैं bubble sort. So जब हम लोग कहते हैं water में, when the bubble is generated, the bubble will scroll up, the bubble will scroll up, and as bubble scroll up, then it will grow in a size. On the similar element, similar line, when you go from this end to this end, you'll find that the largest element comes out first. The largest element comes out first, and that is the reason the name is given as bubble sort. As I told you, you always remember why the name is given, so that automatically you can remember the algorithm behind it. Correct? So let us just get started. The bubble sort is like one of the easiest algorithm ever. You simply say that you want to compare these two elements, and if left hand side is greater, if left hand side is greater, then you want to sort. Then you want to swap. रुको जरा कल के जैसा, let me just put two markers over there. This is like a left side element, let's say right side element, and you compare. So obviously I need to swap this. So 6 is greater than this. Then you continue further. Now you compare the next two element. Again you find that the 6 is greater than 2. 6 is greater than 2. So you find that 2 goes in place. 6 comes over here. Again you continue further. and 6 and 8. Now you find that the 6 is smaller than 8. 6 is smaller than 8, nothing much to be done. You continue further. 8 is greater than 3. As 8 is greater than 3, so 3 is over here, 8 is over here, and again you continue the process. Again you continue the process. You find that 8 is greater than 1. As 8 is greater than 1, your one pass is completed, and with your one pass completed, you must have observed that the highest element reach to the end. That is the reason I call it a bubble sort. कि जब ने शुरुआत किया था, you might have started with the smaller number, but as you reach to the end, you will take the greatest element to the end. That is the reason it was a bubble sort. But by the way, this is only sorted one element. Yes, it is like first pass or first iteration. Why not you repeat the story once again? Oh, you repeat the story once again, and again you start comparing. Again, 4 and 2, 4 and 2, you find that 4 is greater than 2. So 2 over here, 4 over here, and you continue further. 4 is smaller than 6, nothing much to be done. 6 is greater than 3. Yes, 6 is greater than 3. 3 over here, 6 over here, that is good. You continue further. 6 is greater than 1 as well. 6 is greater than 1 as well. So 1 over here, 6 over here. So done, it's over. And Ruko, you can always compare the next element as well. But even though you compare, you find that it is not really matching. Uh, the left hand element is still smaller, so nothing much to be done. So what do you find? The second highest element reach to its final destination. And again, you continue the process. Now you find that 2 is less than 4. That is good. But 4 is greater than 3. 4 is greater than 3. Go ahead. 3 over here. 4 over here. You done the swapping. You continue further. And then again, 4 is greater than 1. As 4 is greater than 1, again it need to be swapped. It is done. You compare the next, nothing much to be done. You compare the next, nothing much to be done. That is good. And now the third highest element reach to its final position. Or you continue the process once again. This is probably the three passes are done. Now the fourth pass. Now 2 and 3, you find that 2 is smaller, nothing much to do. But 3 is greater than 1. 3 is greater than 1. So you find you need to do the swapping, and then you continue the process once again. You continue the process once again. 3 and 4, oh, no swapping is required. 4 and 6, no swapping is required. 6 and 8, no swapping is required. That's it. And what you achieved is that the next element at its final position. Let us just go ahead, make it at the start. And again, you find that 2 is greater than 1. 2 is greater than 1. Do the swapping. This is done. This swapping is done. Next two, no swapping is needed, no swapping needed, no swapping needed, no swapping needed. That's it. Nothing much to be done, and it's over. It's over. The two is at the final position. Now there are no more two elements are left. There's only one element left. So there is nothing that you need to compare. So ultimately, for the array of 6 elements, you have done 5 passes, and in 5 passes you find that your whole array is in sorted order. I hope the algorithm is clear. Still, I will go through the algorithm quickly once again quickly, and it will be good if you could do a paperwork with me. वैसे bubble sort is like easiest sorting algorithm, I know, but still we will follow what the way we are doing. As I said that it will be great if you could do the paperwork along with me. You will be a bit more comfortable. And while doing paperwork, if you at all find that some questions are there, queries are there, please do ask. Let us begin with. Let us begin with what you are saying. We are saying that we want to compare two consecutive elements. So पहले ये दो compare करेंगे, फिर ये दो compare करेंगे, फिर ये दो compare करेंगे, फिर ये दो compare करेंगे, और फिर ये दो compare करेंगे. At any moment, if the left hand side element is greater than right side element, we will do the swapping. So let us begin. 6 and 4. Swapping is needed. I hope you are participating now. The swapping is needed. Yes. 6 is greater than 4. So I need to swap 6 with 4. Okay. Let's go ahead. Next. 6 2. 6 2. Again, you find that the 6 is greater. Left hand side element is greater than right hand side element. So again, go ahead, do the swapping once again. You continue further. 6, 8. 6, 8. Oh, sorry, 6 is smaller than 8. So no swapping is needed. 8, 3. 8, 3. Yes, 8 is greater than 3. So take 3 over here, 8 over there. 8, 1. 8, 1. Again, I find that. So it is over here, it is over here. This is done. So my first pass is completed. First pass is completed. I found the largest element at the end. And then you continue further, you repeat the story. You repeat the story, you start with, what is that? 4 and 2. अगेन पहले से वापस से एंड तक हम लोग सारे कंपेयर करेंगे. 4 and 2, 4 is greater than 2. Okay, that is good. 4 and 6, 4 and 6, sorry, no swapping is required. 6 and 3, 6 and 3, 6 is greater than 3, so please swap, that is good. Next, let's move further. 6 and 1, again 6 is greater than 1, so you again continue swapping it, done. And 6 and 8, again 6 and 8, no swapping is required, that's it. The second pass is completed and it's done. You continue further, you continue further, you start with this. What is next? 2 and 4, 2 and 4, 2 and 4, no swapping is needed. But now you find that 4 is greater than 3, 4 is greater than 3, yes, swapping required. You continue further. 4 and 1, 4 and 1, 4 is greater than 1, so again swapping is required. 4 and 6, no swapping needed. 6 and 8, no swapping needed. Again, the element reach to its highest, what that appropriate position. You compare it once again. 2, 3. 2 is not greater than 3. Okay, that is good. Next, but 3 is greater than 1. 3 is greater than 1. So let's take 1 over here. Let's take 3 over here. And then again you compare. 3, 4, no swapping needed. 4, 6, no swapping needed. 6, 8, no swapping needed. That's it. And the 3 reach to its position. You continue once again. 2, 1, 2, 1. The last pass. Yes, 1 is over here. 2 is over here. Done. And then you continue the process. 2, 3, 2, 3, no swapping needed. 3, 4, no swapping needed. 4, 6, no swapping needed. 6, 8, no swapping needed. So that's it. All is done and all elements are sorted. So your algorithm is like very simple. At any moment, we are just comparing two back-to-back elements. If you at all say that this element is J, if you say that this element is J, this element is probably J plus 1. So you are comparing jth element with j plus 1th element, and if you find that jth element is greater than j plus 1 element, if jth element is found to be greater than j plus 1 element, then you do the swapping. So how do we write a code basically? I guess writing code should be a very easy job. Let me simply say that for j is equal to 0, j is less than n minus 1. Please note, I said less than, I didn't say less than or equal to. And at the same time I said n minus 1 as well. So make a note of both of them. And then inside this, I want to check if a of j is greater than a of j plus 1. A of j is greater than a of j plus 1. Is it true? Yes, it is consecutive elements that we are comparing. And if it is greater, what is to be done? If jth element is greater than j plus 1 element, what we need to do? Yes, we need to simply swap the jth element with j plus 1th element. This is what the logic I guess we seen right now. But you understand that this was a logic for your one pass. This was a logic for one pass. And how many such passes I need to complete? This is a logic. This is a logic for one pass. How many such passes we need to conduct? Oh, n minus 1 passes that we need to conduct. And if you at all think of n minus 1 passes for I is equal to 0, I is less than n minus 1, I plus plus, please note the outer loop is only counting the passes. Outer loop, अगर आपने ठीक से note किया है, this I is not used in the inner loop. So it is only just to ensure that just to ensure that n minus 1 passes are done, just to ensure that n minus 1 passes are done, and this part is actually conducting the pass. Is it so? Yes, it is so. Nothing much is there. Why not we go ahead? Why not we go ahead and we create a Maven project? नहीं Maven project नहीं, sorry, हम लोग जावा पढ़ रहे हैं ना. So new. Okay, core Java project. I create a Java project, and yes, we will continue on to the sorting. I hope आपका Eclipse ready है. Things you people are done, and if it is done, I can say finish. Done. Okay. Let me just go ahead, create new class, and obviously the name of a class is, let's say, sorting main. All right. Yeah. So this is good. We have like a main function, and we are trying to write a method. Public static void. Let's say bubble sort. You can name bubble sort, and for the bubble sort, you can pass the array to be sorted. Array to be sorted. The logic was pretty simple. For you can try to reiterate on over the array. J is equal to 0, j is less than length minus 1, j plus plus, and you are comparing if ARR of j is greater than ARR of j plus 1. So jth element with its next element, what is to be done? Oh, all I need to do is that I need to swap. As I hope yesterday I told you, it is really good idea to talk to yourself when you are typing a code, so that behind the scene you are also understanding what you're doing. I hope आप लोग these tricks you people are trying. So error of j is equal to error of j plus 1, and then error of j plus 1 is equal to 10. Done. So this will take care of swapping. So the basic idea is done. It's not a problem. But this is, as I told you, this is for one pass. So what we are done in your one pass, that compare consecutive elements, and if the what is that left element is greater than right element, then swap. That's it. That is like a basically logic that we have used, but we want to say that we want to repeat this for n minus 1 passes. And how do you repeat this for n minus 1 passes? Is I was trying that for I is equal to 0, I is less than, again ar dot length minus 1, I plus plus. So we are repeating the whole process for for n minus 1 times. We are repeating the whole process for n minus 1 per time. So I'm simply saying that let's conduct, or let's say execute, whatever, execute n minus 1 passes. That's it. So outer loop is only for the comparison. Sorry. Let us go ahead. I want to create an array. I guess yesterday also I created an array, but that was in like a yesterday's project. So I thought of creating an array route right now once again. And the array is, let's say we have got 6, we have got 4, we have got 2, we have got 8, we have got 3, we have got 1. That is good. And system.println arrays. Sorry. Arrays dot sort, and arrays dot sort. Sorry, arrays dot to string. Using arrays dot to string, I can print this array. Okay, that is good. But this was like before sorting. This was definitely before sorting. How do I print it after sorting? I'll say that same way. I can also think of printing it after the sorting. Meanwhile, I want to call the code selection sort. नहीं selection नहीं, क्या अभी हम लोग bubble sort कर रहे हैं ना? Okay, So bubble sort, you pass the array. It's done. So will it work? I believe so. Let's check. Oh, is it working? Oh, look like. Yes, the things are going well. I guess there is no trouble with this. Chalo, I guess you people also want to try it. Please go ahead and try it. Don't only try it. Also, you have any questions, please do ask. Good. So we are able to do that. And as I said that our flow is very simple. We'll first get the philosophy. We will try the algorithm on paper twice at least. And then if you still have any doubt, you can always ask. And if no, then we can move on. We'll write a code. As code is written, probably we want to also talk about the efficiency. Oh yes, and talk about the efficiency and talk about the time complexity. And so let's understand that. By the way, you must have understood that how many passes are done? Oh, there are probably n minus 1 passes. So you find that when I is equal to 0, when I was equal to 0, at that time, how many comparisons are done? Internally, ये जो आपका loop है, यहाँ पर how many comparisons are done in this loop? Yes, 5 comparisons. So you have done total 5 comparisons, or let's say inner loop 5 iteration. So I'm talking about like inner loop, jth loop is a 5 iteration. But if you have seen it very carefully, when I is equal to 1, or when I is equal to 2, or when let's say I is equal to 3, I is equal to 4, all the times there were only 5 iterations, isn't it? All the time we went through, all the time we went through the whole array, and every time we are doing 5 iterations each. And if you are doing 5 iterations each, the total number of iterations, if you have done addition, I guess that comes out to be 25 iterations. Okay, that is pretty simple. However, however, let's just go ahead and what I can say, I want to look for what is exactly the time complexity. A number of iterations. Can you tell me now the inner loop total number of iterations? Inner loop total number of iterations right now for 5, sorry, for 6 elements, we have seen that there are total 25 iterations. तो ये तो हम लोगों ने on paper किया था. I'm saying that in general formula, only in general formula, you find that n minus 1 passes, n minus 1 passes, and n minus 1 comparisons, n minus 1 comparisons for each pass. N minus 1 passes and n minus 1 comparisons for each pass. And with this, you can always say that it is n minus 1 into n minus 1 iterations. If n minus 1 into n minus 1 iterations, I say that the time required will be proportional to number of iterations. Just go ahead, solve it, n square minus 2n plus 1. I hope this is correct. And if you recall the theory of approximation that we have seen earlier, all lower order terms can be neglected. As you neglect all no lower order terms, you find that it is like n square, and then the time complexity can be obviously said to be O n square. I hope this is pretty simple, pretty straightforward. The things are with you. So if you've seen whatever implementation that we have done right now, selection sort is faster or bubble sort is faster? Whatever implementation that we have done right now, the selection sort is faster or bubble sort is faster? So you always find that no, not really, not really. अगर आप लोग कल का प्रोग्राम ठीक से देखते हो, there were only 15 iterations were there. Have a look at this. There were inner loop was repeated only for 15 times, and for the same array For the same array, today it is repeated for 25 times. 25 times. What I want to tell you is that as far as running time is concerned, as far as number of milliseconds or microseconds are concerned, you will always find that the selection sort in this implementation, I'm saying that with this implementation, selection sort will go faster than the bubble sort. But as far as time complexity is concerned, you find that time complexity is still remaining same. So ऐसा क्यों हो रहा है? Because time complexity is an approximate measure of the time. It is a time complexity is an approximate measure of the time. It is not the exact measure. So in this particular case, I can say that with the current implementation, the selection sort can go faster, or the selection sort will have the lesser running time, will have the lesser running time as compared to the bubble sort. The actual time wise, you will always find that, I repeat, मैं बार बार एक word use कर रहा हूँ, with this implementation. So with this implementation, you always find that the selection sort is going faster as compared to the bubble sort, because the number of iterations are reduced there. However, the next question, so sir, can we really improve the bubble sort? Can we really improve the bubble sort? And my answer is yes. There likely chances are that you can always improve the bubble sort. And what do you mean by improve the bubble sort? I'll just say that I'm repeating algorithm once again. And when I'm repeating algorithm once again, I may not do all passes, but just pay attention and try to appreciate that whatever efforts that we have taken at this moment, give me a minute. Yes, again we are comparing two consecutive elements. As you are comparing two consecutive elements in a first pass, you find that 6 is greater than 4. Yes, we have done swapping. Let us continue further. No swapping is needed. Sorry, again 6 is greater than 2. So swapping. In this case, no swapping is needed. You continue further. 8 is greater than 3. You do the swapping. And then again you continue further. 8 is greater than 1. Again you do the swapping. And now you realize that, see it carefully, you understand it very well, that the largest element is reached to the end. If you know that the largest element reached to the end, to be frank, in a next pass, there is no need to compare the further one. I hope you are getting my point. अगर आपको already पता है 8 is already reached to the end and 8 is already the greatest element, so जब आप लोग second pass के लिए जा रहे हो, वापस से 8 के साथ compare करने की कोई आवश्यकता नहीं है. Even though the code that we had written, it was still doing the same, वो बात अलग है, but it was always possible, I'm trying to tell you. Now again you find that 4 and 2, so 4 is greater, so you swap, no swapping is required. 6 is greater than 3, a 6 is greater than 3, okay, that is good. And again you continue, 6 is greater than 1, okay, that is all right. Now see it carefully. Now you know it very well, this element has reached to its final position. There is no need that you really compare this. Why you really compare this? क्योंकि फर्स्ट पास में लार्जेस्ट एलिमेंट ऑलरेडी एंड में गया होगा. वैसे भी अगर आप लोग इसको कंपेयर करते हो, आपने नोट किया था, वैसे भी स्वैपिंग नहीं होने वाला है. वैसे भी स्वैपिंग नहीं होने वाला है. इट वाज नॉट एट ऑल नीडेड. करेक्ट. एंड यू विल सी द सिग्निफिकेंट डिफरेंस अगर आप लोग लास्ट वाला पास नहीं करते हो. हैव अ लुक एट दिस. सो in a first pass, when probably I is equal to 0, I'm saying that the number of iterations, ये जो आपका inner loop है, the inner loop के जो iterations है, when I is equal to 0, yes, you need 5 iterations. But when I is equal to 1, in a second pass, you actually need 4 iteration. Fifth वाले iteration की जरूरत ही नहीं है. Fifth वाले iteration की जरूरत ही नहीं है. And you continue it further. You again understand that a 2 is less than 4, nothing much to be done. But now 4 is greater than 3, you do the swapping. Again you compare, 4 is greater than 1, you again do the swapping, correct? And then, to be frank, again the next comparison is not at all needed. Next comparison not at all needed. In this pass, 1, 2 and 3, the three comparisons are probably more than sufficient. And then you continue further, you can always see that there are two comparisons, and the last one, there is like only one comparison is also sufficient. There is absolutely no need that every time you want to go till the last last element, because those elements are already the largest elements and they are already, reached to their final position. So unnecessary comparison that we had done it in an earlier code was not really necessary. Then you ask the question, so sir, how we can improve on this, or how we can improve on this? That can be done like quite easily. That can be done quite easily. What you are simply saying, yes, absolutely. What you are simply saying, जब last time यहाँ पर आपने क्या किया था, j is, have a look at this, j j is less than n minus 1. Please make a note, j is less than n minus 1. J is less than n minus 1. All I need is that I need to consider one more factor into that, minus I. Minus I, you understand that in the first pass, I is equal to 0. I is equal to 0, so it will go up to n minus 1. In a second pass, I is equal to 1. So it will go for n minus 1 minus 1. Means it will go up to n minus 2 only. In the next pass, I will be equal to 2. I will be equal to 2. So this will go basically till n minus 3 only. And then when n is equal to 3, it will go to the n minus 4 only. That's it. Nothing much you need to do it. So all changes that you need to do over here, इस पूरे कोड में अगर आपको कुछ चेंज करना है तो सिर्फ इतना एक पार्ट चेंज करना है, rest entire code remains same. But what is the advantage? What is the advantage? The advantage is that now you compare the number of iterations. Can you compare the number of iterations now? The number of iterations right now, as you seen, the first one, they're like a n minus 1 iterations. And the second pass, n minus 2 iterations. And this way, the last pass, like a 1 iteration. I believe this is exactly same as of selection sort. You find that the total आप लोगों ने करके देखा होगा, I'm very sure. The total जो आप लोगों ने किया था, I guess again it comes out to be 15. Oh, that is good. And then I can simply say that the time complexity, a time complexity will be same as, a same as selection sort. Even the running time is same as selection sort. The time complexity is same as selection sort. Even the running time is same as selection sort. That is what all you can do. By the way, ये जो था, I I refer this as something called as a improved bubble sort. This is improved not in time complexity. Time complexity इसका भी O n square है, इसका भी O n square है. But as far as running time is concerned, this is bit better as compared to the other one, earlier one. Okay, that is good. And if you understand this, you can always go there. You can always copy paste this, and same logic. All I'm saying is that I need to just do one change, minus I into that, and I can say that this is nothing but improved bubble sort. All right. And if you, instead of bubble sort, if you try to call kind of improved bubble sort, am I going to get the same result? I believe yes, you should be able to get the same result. Why don't you run it once again? And you find that yes, your array is still sorted. I hope ये कोड मुझको शेयर करने की जरूरत नहीं. It is hardly one change is to be done. Please go ahead and do it. Please go ahead and do it. So it is hardly minus i's to be added as far as code is concerned. तो आप लोगों ने नोट किया, एक दो कैरेक्टर्स इधर उधर चेंज करने से टाइम कॉम्प्लेक्सिटी चेंज नहीं हुआ है, बट व्हाट इज चेंज, द रनिंग टाइम इज इंप्रूव्ड अ लॉट. Running time is improved a lot, and that is a good thing. And now, if this is clear, I want to still think of optimizing it even one more step ahead. तो सर इसका भी ऑप्टिमाइजेशन हो सकता है. Yes, this can be still optimized. This can be still optimized. Consider a case. Consider a case that your array is already sorted. What if your array is already sorted? What if your array is already sorted? With the logic that we have written right now, the logic that we have written right now, we are still doing 15 passes. Oh, we are still doing 15 passes. Even though your array is already sorted, we are still checking, पहले pass में 5 comparison, second pass 4 comparison, next pass 3 comparisons. तो वैसे भी हम लोग ये कर ही रहे हैं. तो सर, is there any way that we can do it better? हम लोग क्या कर रहे हैं बबल सॉर्ट में? हम लोग बेसिकली क्या कर रहे हैं बबल सॉर्ट में? हम लोग कंसेक्यूटिव एलिमेंट चेक कर रहे हैं. And at any place, if the lower element is greater than lower element is greater than the higher element, the upper element, we say that we want to swap them. We want to swap them. So ultimately, suppose that if your array is already sorted, have a look at this. If your array is already sorted, something like this. Wait for a minute. I don't need this now. I'm not bothered about this. And let's consider that your array is already sorted. 1, 2, 3, 4, 5, 6. Yes, done. So I'm saying that in this particular case, if you follow this algorithm, what will happen? In a first pass, you find that 1, 2, no swapping needed. 2, 3, no swapping needed. 3, 4, no swapping needed. 4, 6, no swapping needed. And 6, 8, no swapping needed. So what I'm saying is that at any pass, when you realize that, at any pass, when you realize that no swapping is needed, what does it mean? What does it mean? It simply means that your array is already sorted. And if you at all say that your array is already sorted, my question is very simple. Why to go for a next pass? I'm just making a simple logic. See, what I'm saying is that if array is already sorted, you compare the consecutive element. You say that 1 is smaller than 2, no swap needed. 2 is less than 3, no swap needed. 3 is less than 4, no swap needed. 4 is less than 6, no swap is needed. 6 is less than 8, no swap is needed. It only means that all elements are already arranged, already organized in one particular way. And if all elements are organized in ascending order, it is very simple. There is no need to go for a next pass. Why are you wasting your time? Okay, I understand that. But the question is that how do I keep a track of whether any swap is done or not? How do I keep a track of any swap is done or not? So what I'm saying is that why don't you declare a flag? Why don't you declare a flag? So I'm saying that you can have some flag declared. You can have some flag declared, and into the flag, have a look at this. You can have something, let's say swap flag. So we can write swap flag is equal to false. Swap flag is equal to false. At any moment, at any moment, if at any moment, if there is a swapping, you just go ahead and say that the swapping is done. So I'm making swap flag is equal to true. Swap flag is equal to true. And once it is done, now at the end of the pass, see, before the pass, we said the swap flag is equal to false. During a pass, if anywhere the swap flag, whenever swapping is done, I simply say swap flag is equal to true. At the end, if I find that the swap flag, the swap flag is still false, swap flag is still false. What is the meaning of this? In this particular case, I also understand that there is not a single swap done in an earlier pass. And if it is false, so there is no need of repeating even the next iteration. I can directly say break and I can come out. I can directly say break and I can come out. So what is this? I can say that this is not only the improved bubble sort, I can say that this is, let's say, more improved bubble sort. So like an improvement at one stage ahead. But what you achieved into this? What you achieved into this? Number of iterations आपके कम होंगे क्या? Number of iterations तब कम होंगे if your array is already sorted. If your array is already sorted, then number of iterations are reduced. Can you tell me, if array is already sorted, total number of iterations that the inner loop see, how many are there? ओनली 5 इटरेशंस, दैट्स इट. इनर लूप एक बार तो आपको पूरे इटरेशंस करने ही पड़ेंगे, एक बार तो पूरे इटरेशंस करने ही पड़ेंगे इफ योर array is already sorted. And this is nothing but you can consider it as a best case. This is nothing but a best case. Best case, what is that? Array. What is the best case that we have got? The array already sorted. And if array is already sorted, what do we see? The inner loop inner loop is repeated, or other repeated नहीं कहना चाहिए, repeated executed only once, only once. So number of iterations will be simply n minus 1, and obviously the time required is proportional to n minus 1. N is large enough, you can ignore minus 1, and you can simply say that time complexity is O of n. What we are discussing over here is a best case of selection sort, sorry, bubble sort. Please understand that this is possible in this implementation. अगर आप लोग ये वाला implementation कर रहे हो, then what is the best case? Then there is no best case. Even in the best case, you are still going with all the iterations. It will still O(n) square. So many times, people keep come down and ask me, so what is the best case of bubble sort? I always say that it depends on your implementation. It depends on your implementation. It is not like that कि you can say that नहीं नहीं ये faster है वो faster, बिल्कुल नहीं. It depends on your implementation. आपका implementation क्या है उसके ऊपर चीजें डिपेंड करेगी. अगर आपका ये implementation है, the best case is still O(n) square. लेकिन अगर आपका ये वाला implementation है, अगर आपने flag use किया है, then in that case I can say that in best case there is only one pass will be executed. Only one pass is executed, the time complexity will be O of n. So whenever the question is asked in interview, you need to answer, well, not a by-hearted answer, right? So chalo sir, implement करके देखते हैं. Will it take time or not at all? This is like a very simple one. As I said that, I'll just copy paste this once again. And I call this as more improved bubble sort. In a more improved bubble sort, what I'm looking for a Boolean variable, and I'm calling it as a swap flag, and this swap flag is equal to false. Okay, that is good. You continue further. If at all swapping is needed, you just add a line swap flag is equal to true, and at the end of the iteration, please note at the end of the iteration जो inner loop आपका खत्म हो जाएगा, when your inner loop is completed, at that time, at the end of the inner loop, you check if it is not swapped. If it is not swapped, simply say break and you come out of the loop, and this will ensure that if array is already sorted, you will be having, next passes will be actually skipped. Next passes will be actually skipped. So will it work? To be frank, in this case उसका कुछ ज्यादा फर्क नहीं पड़ेगा क्योंकि हमारा array already sorted नहीं है. I'm just calling it for your comfort so that you understand this and you get the result. Obviously the result is same. I hope this is clear, and what is happening? Please go ahead and try it. Any questions are there? Do ask. Good. So we talked about bubble sort. We talked about improved bubble sort. We talked about more improved bubble sort, and we also seen that with the more improved bubble sort, we can handle a best case in a bubble sort. To be frank, तो सर ऐसे ही मैकेनिज्म हम लोग सिलेक्शन सॉर्ट में नहीं कर सकते थे क्या? Unfortunately not. Selection sort, you can just go back, you can just do paperwork, and you realize that keeping a flag kind of technique, ऐसा कुछ नहीं है कि आप लोग सब जगह पे एक ही टेक्निक यूज करो. It is not possible. And if this is clear, now we should be going ahead and we should start discussing on to something called as a insertion sort. So should we move on insertion sort? Anywhere that you find that the things are going bit fast,